Okay, so I hope we're recording. I've been given this question about binomial expansion. So the first three terms in the expansion are ascending powers of x of 1 plus px all to the power of n, or 1 minus 18x plus 36p squared x squared. Now, whenever I do these sort of questions, I'm trying to look for some clues about this. Now, the first clue that I'm giving is that the very first term, that one there, um, is a positive. My second term there is a negative, and then my third term is a positive. So because it's oscillating between positive and negative, I know that my p-value in the original bracket is going to be a negative value. Now that's the first thing that it gives me. The second thing which I am thinking about this is because I've got two unknowns, I'm going to have to try and figure out and use a bit of information in order for me to try and um, deduce this. And normally, as soon as you have two unknown variables, there's going to be two equations that I'm going to need to use. So if I was to try and expand this out, what I'm going to do is I'm going to use this down here. Now, this bit here is basically your n choose r. So it's essentially thinking about Pascal's triangle. So your 0th position is the very first term, and that's always 1. Always 1, okay, in Pascal's triangle. Um, and because my first in the bracket, it's got the 1 there, and I've got my first term, which is 1, that all makes sense. So that's fine. So really, I'm bothered about the second and third term. Now, to get my second term with the unknown power, what I need to do is I now need to actually say I've got n power. Good lord, that was terrible. I've lost my pen, so I'm having to use my finger. So I've got the nth power, and I'm choosing the first position. Okay. Now what that looks like is it's going to equal n factorial over 1 factorial, and then it's going to be n minus 1 factorial. Okay. Now, because you've got it like this, what you essentially have, if you were to simplify it down, and there's a really good video on, I think it's by some maths exercise 8b, because the first one, because it's n factorial up here, it's essentially n times n minus 1 times n minus 2 times n minus 3, so on and so forth. And then below, what you've got, because you've got 1 factorial, well, that's just 1. What essentially you've got is n minus 1 as a denominator times n minus 2, n minus 3, so on and so forth. And if you cancel that out, what that essentially gets you is n. Okay, so it gets you n. Now, because it's just n here, now if I'm thinking about my my terms, and I know that it's going to be negative. I wonder if I can draw with this. Let's give it a go. Because I've got negative 18, 18px from memory. Sorry, x, sorry. Negative 18x. I know what that basically means. Oh, unbelievable. Is I've essentially got the nth position now times by p x, because as we go up the binomial expansion, you increase the second term by a power of 1 each and every time. So it started off as to the power of 0, so now it's to the power of 1. Hence why I've got p to the power of 1, x to the power of 1. And then because the x is now cancelled, what I'm essentially left with, it'll probably be easier if I just rub it out. What I'm essentially left with is negative 18 now equals n times p. Okay, so that's the second term. Now, when it comes to the third term, what I now need to do is I'm going to be looking at n choose 2 now. So it's going to be n choose 2. God, that's a terrible 2, but we run with it. Okay, so n choose 2. Now with that, what you essentially have is now n factorial over 2 factorial and then n minus 2 factorial. Now this one's slightly different in the sense of, so now you have n, so your numerator will be n times n minus 1 times n minus 2 times n minus 3 times n minus 1, blah, 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 blah. The denominator is now going to be 2 times 1, so essentially 2, okay? And then you've got n minus 1, n minus 2, n minus 3, n minus 4, blah, 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 blah. Now, because it had, sorry, n minus 2, n minus 3, n minus 4, because you don't have that n minus 1, on the numerator, you're going to have n, open bracket, n minus 1. Okay, put that all over. So that's the choose position. So if we go back now and think about, well, if I've got the, in a sense, the third term, well, that's now my squareds. Okay, that's now my squareds. What I essentially have is I now have p squared x squared times n minus 1 over 2. So I have n open bracket n minus 1 over 2 p squared x squared, which equals, and if I just go up, I think it was 36x squared. Yeah, 36p squared x squared. Okay, so 36p squared x squared. What I can do is if I take a factor of p squared and x squared out of both sides, I now have n open bracket n minus 1 over 2 equals 36. So if I multiply both sides by 2, and I'm going to expand the numerator, so I now get n squared minus n, which equals 72. I can now move that over onto the same side. So I now get n squared minus n minus 72 equals 0. And if I was to factorize this, I get n minus 9 and then n plus 8 equals 0. Therefore, what I'll have is I will then have n equals 9 or negative 8. Now, going back up to the original question, thinking about n equals 9 or negative 8, what I have is I've got this line here. So it says, given that n is a positive integer, find the value of n, find the value of p. So because I know it's a positive integer, I now know that n must be 9. N must be 9, okay? Can't be negative 8 because it has to be positive. So if I know that n equals 9, I now go back up to this original bit up here. So if I can now substitute n equals 9 into here, I now have minus 18 equals 9 times p. Therefore, p now equals negative 2. Really, really tough question, that one, actually. And essentially what you need, and I believe it's in the formula booklet, but essentially what you need is you need to have this. If you don't have that formula, which I think is in the formula sheet, if you don't have that, then it's going to be very, very tricky because you're essentially needing to work out which coefficient, the coefficients, how much you'll need to multiply them by. And that's essentially using Pascal's triangle. But because you've got that unknown power, you have to use this formula here in order to try and eliminate that. And then you've essentially, as I said right at the beginning, you've got your first equation here, and then just later on, you actually pick up your second equation just here. Okay, so that's your second equation there. I do apologise for the fact that it was so sort of clunky, but that was really the best I could do without my pen. But I hope that helps. Let me know tomorrow if that doesn't. But I don't expect you to see this now because it is 9:20. But yeah, let me know. All right, cheers. Bye bye.